Hello students, welcome to We Learn. In this video, we will see about activity 1.9 from your chemical reactions and equations. This is a part 3 video. Already part 1 and 2 have been posted in our channel. If you didn't visit them, go and visit them at first, learn those two parts and then come back to part 3. Let me give you a small introduction about types of chemical reactions. There are 4 types of chemical reactions. First one is a combination reaction, where two reactants combine together to form a single product. Here, bond formation is taking place. Okay, next one is a decomposition reaction, where a single reactant will decompose into more than one product. Okay, here breakage of bond is taking place. Next one is a displacement reaction. See here, AB reacts with C and forms AC plus B. Here B is displaced by C. So it is a single displacement reaction. Next one is a double displacement reaction. See here, AB reacts with CD, where B is displaced by C, and here C is displaced by B. So double time the displacement is taking place. So it is a double displacement reaction. Already we have covered about combination and decomposition reaction in our previous video. Here this activity 1.9 belongs to the displacement reaction. Okay. See, this is an a pictorial representation. Displacement reaction, already I told you, right? AB reacts with C and B is getting displaced by C. So it is a single displacement reaction. Example is iron reacts with copper sulfate and forms copper plus iron sulfate. See here, the copper is being displaced by iron. So it is a single displacement reaction. See, this is activity 1.9. Take 3 iron nails and clean them using a using a sandpaper. You have to clean the iron nail at first because it would have been rusted, right? So to clean all those, we have to rub them using a sandpaper, and then take 2 test tube, mark one as A and mark the other one as B. Okay, in each test tube add about 10 ml of copper sulfate solution. Take only the test tube B. One is for reference. Okay, so we are going to do the experiment only using the test tube B. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. See here, we have to take 2 iron nails, we have to tie them tightly, and then we have to immerse them inside the test tube. Okay. Why we have to tie them means, if we don't tie them, we cannot take the iron nails out, right? So that's what we cannot put our fingers inside the test tube, so we have to tie them with a thread. The iron nails has to be tied with a thread and it has to be immersed inside the copper sulfate solution. So the test tube A has to be kept aside for comparison purpose. For reference, we will use test tube A. See, after 20 minutes, take out the iron nails from the copper sulfate solution and compare the intensity of blue color of the copper sulfate solution in both the test tube. After 20 minutes, we will take it out of the test tube. We will take the iron nails out of the test tube and we will compare both the test tube A and B. Okay, we are going to see how the intensity of blue color is between both the test tubes. See here, this is after the experiment. See, this is a pure iron nail, and this is the one which is inserted inside the copper sulfate solution. And next one, this is the test tube. This is only a copper sulfate test tube. We have kept our test tube A for reference, right? This is that one. And this is the copper sulfate solution after reacting with the iron nail. Okay. See, the reason is here only iron is present. Here, after inserting a iron nail inside a copper sulfate solution, a single displacement reaction is taking place, where the iron is getting see here, in copper sulfate solution we are inserting iron nail, right? So iron displaces copper from the copper sulfate solution and the copper is getting deposited in the iron nail. This is the reaction taking place. That's what here we can able to see a reddish brown color. Okay, the brown the color of copper is reddish brown, so the iron nail is changed to reddish brown color. Next one is the see here we can see deep blue color, right? So the color of copper sulfate is deep blue. Okay, where the color of iron sulfate is light, light green. So here the blue color fades. See here, why does the iron nail become brownish in color and the blue color of copper sulfate solution fades? See, the following chemical reactions is taking place. As I already told, the iron displaces copper from the copper sulfate solution and form ferrous sulfate solution, and copper metal getting deposited in the iron nail. So in this reaction, iron has displaced or removed another element, copper from copper sulfate solution. This reaction is known as displacement reaction. So other examples are zinc and lead also reacts in a similar way. Here zinc metal is taken and it is allowed to react with copper sulfate solution. Aqueous means it is dissolved with water. Okay. Uh, See here, copper is being displaced by zinc. Okay, so zinc sulfate solution is formed plus copper metal. So we saw in iron nail also it is getting deposited in a solid state, right? So solid. Next one is a lead. Okay, lead reacts with copper chloride. Okay, lead reacts with copper chloride in aqueous medium and forms lead chloride plus copper. Okay, see here zinc and lead are more reactive elements than copper. Okay, they displaces copper from its compounds because see, copper as a strong can form a strong metallic bond than zinc and lead. So, see, if the bond is stronger, then more force is required to break the bond. Whereas in case of zinc and lead, they don't form that much. See, they also forms a stronger bond, but comparatively, copper will form so stronger bond. That's what the bond between copper and some other element is very hard to break, whereas zinc and lead can be easily broken, so they are more reactive. If it is if it can be broken easily, then it is more reactive. If it is more stronger, if the bond is more stronger, then it is less reactive. Okay, so like my video, share my video and subscribe my video. Thank you, students.